Blockchain is the technology that could transform finance forever. Today, we'll explain what blockchain is, why it matters, and how it works in simple terms. At its core, blockchain is a ledger made of linked blocks of data. Think of them as digital records chained together in order. Two features stand out: transparency and security. A blockchain ledger can be open to view and design, so records are very hard to change. Instead of one central authority, verification happens across many participants. That decentralized verification helps make the system resilient and trustworthy. Blockchain started with cryptocurrencies, but its potential goes far beyond money. Supply chains, voting systems, and digital identity are all possible applications. Over the next minutes, we'll show how blocks link, how consensus works, and where blockchain can make real-world impact. Let's start with the building blocks. Every block contains a set of transactions or data, a timestamp, and a reference to the previous block. That reference is what creates the chain. Each block also includes a cryptographic fingerprint called a hash. That hash uniquely represents the block's contents and links it to the next block. If any data in a block changes, the hash changes too. That break in the chain makes tampering immediately visible to anyone checking the ledger. New blocks are added in sequence. Once many nodes agree a block is valid, it becomes part of the official history and is very hard to remove. Think of each node as a copy of the ledger. When a new block appears, nodes compare notes and confirm it matches rules before accepting it. This combination of linked blocks and shared copies is how a blockchain preserves an auditable history that anyone can examine. Transparency comes when participants can view the ledger's transactions. Public blockchains offer open visibility, which builds trust through verifiability. Security relies on cryptographic techniques. Digital signatures prove who authorized a transaction without exposing private details, preserving both security and privacy. Because every change affects linked hashes, attempts to alter past records are obvious and require altering many blocks across many copies simultaneously. Public blockchains trade off some privacy for transparency. Permissioned blockchains let trusted participants retain more privacy while keeping shared verification. No system is flawless. Blockchain reduces many risks but introduces questions about scalability, energy use in some designs, and governance choices. Understanding security means looking at both cryptography and network design. Together they create a robust foundation for trustworthy digital records. Decentralization means many independent parties validate transactions. This reduces reliance on any single authority and spreads trust across the network. Consensus algorithms let the network agree on which blocks to add. Proof of work and proof of stake are two common approaches with different trade-offs. Proof of work uses computation to secure the network. Proof of stake uses economic commitment. Both aim to make malicious changes expensive or infeasible. Because many nodes check each block, dishonest actors find it difficult to rewrite history unless they control a large portion of the network. Decentralized verification also improves resilience. Networks can continue operating even if some participants go offline or act maliciously. Design choices shape performance, cost, and security. That's why different blockchains exist for different purposes, from fast payments to tamper-proof records. Supply chains benefit from blockchain by recording provenance. Each step can be logged so buyers can verify where goods originated and how they move. In voting, blockchain can offer tamper-evident records and transparent tallies, helping increase trust while preserving voter privacy through careful design. Digital identity on blockchain can give people control over personal data, enabling selective sharing without surrendering centralized control of information. Beyond those examples, industries from healthcare to real estate are experimenting with blockchain to improve transparency, speed, and trust. Blockchain is not a silver bullet. It's a tool that, when applied thoughtfully, can solve specific problems around trust and record keeping. If you want to learn more, explore how different blockchains handle consensus and privacy, visit our resources to dive deeper and stay informed.